Hello. Do we Hello everyone, am I audible? Am I audible, folks? Cool. Yeah, so welcome back everybody. Uh, yes. So we are going to discuss a very fundamental thing today. Yeah, I am doing good, Uzair. Thanks for asking. I'm doing much better, feeling much better today. Thanks a lot for asking, everybody. I hope all of you are also doing good. And yeah, cool. How many people have joined yet? There are 35 people. I am hoping that a few more will join. But yeah, we are going to discuss a very fundamental thing today. So basically, for today and most likely for the next class as well, we are going to discuss the storage layer. Okay, we are going to discuss the storage layer. Oh, the screen has not been shared. Just a minute. Can you guys see the screen now? Cool. Yeah. So today we want to discuss this. So okay, what all have we discussed till now? We have discussed about the entire architecture. We have discussed about the caches. We have discussed about a couple of system designs, how to design a real life system. We have seen a couple of them. Today we are going to discuss the storage layer. We have not talked a lot about it today till yet. Today's class is so okay. Whenever I say storage layer across all the batches that I have taught till now, the very first thing that comes to people's mind is SQL versus NoSQL, right? People actually want to jump to SQL versus NoSQL, which makes sense, which is the hot thing out there. But trust me, the even a even a thing which comes before that talks about the basics of any DB. Okay, talks about some concepts that are relevant for any kind of storage, and knowing those things for a SD2 level or for even for a SD1 level is it's good to know these things for SD1 level. For SD2 levels, it's a must have. Okay, so we have seen several candidates who do not know those basic concepts, and that's a clear no. So today's class is going to be very important for your interviewers, for your interviews, or in fact even once you join a company, this knowledge is very essential. Okay, cool. So we are going to discuss basic properties that some DBs would want to give you, or let's say not even talk about. Okay, Uzair, that does not fit very well in today's class, but we'll be covering that maybe in one class for sure. Well, that's a promise that I'm making, but maybe not today. Okay, cool. So we are discussing about the storage layer here. Let's look at any example. Let's look at any real life example where you would see that why studying these things make a lot of sense. Okay, so let's take an example of, let's say you're trying to build a book my show. Okay, and let's say the data that for book my show is stored in some tables. Okay, it's a relational database that they are using. Do you guys first of all know what a relational database is? Do you know what a relational database is? A relational database is that when you have the data stored as tables, and those tables can have some relations, can have some sort of a relationship amongst them, right? So that is what is called as a relational database. Okay, cool. And this actually comes from a very good mathematical definition, but most likely we'll be discussing that when once we take the DBMS lectures. Cool. Now let's look for a book my show example. The data is, let's assume, stored in relational databases, and the table that we are talking about is this, the movie booking table, the table which actually has the meat of the problem, that all the bookings for a particular movie that are stored in this table. Okay, the columns are going to look something like this. Let's say there is a column for a movie name, then there is a column for a show ID, then let's say there is a column for what specific seat number we are talking about, and let's say then there is a column for status. Okay, so I will just take an example. So let's take any movie name. So let's say Batman. Let's say the show ID. So let's say Book My Show is selling tickets for Batman across multiple theaters, right? So you are actually saying across multiple show IDs. So let's say there is a show ID 1, 2, 3, and so on and so forth for Batman. And now for the show ID 1, you're going to have a set of seats. Does that make sense? And for every seat, you're going to have a different entry in the table. So let's say there is a seat number 1, there is a seat number 2 again with show ID 1, seat number 3 again with show ID 1, and so on and so forth. Okay, and all of them have the same name, movie name, Batman. Now, at the very beginning, let's assume all the seats for this show ID 1 were empty. Okay, cool. Now, what is the charter of Book My Show? The charter for this application Book My Show is that you would want multiple people to try and book tickets at the same time. Does that make sense? And let's assume till this point in time we do not know about anything fancy. How would you go about building it? A very very simple way of building this would be actually running some SQL queries. Does that make sense? So what would you do? Whenever let's say somebody wants to book a particular seat for Batman at a particular show ID, what would you do? You would just make a SQL query, right? So what would that query look like? That query would look something like this. You would say select all from that particular table. So let's say from movie bookings. Okay, you want to select all from movie bookings. Now a where clause where you will say the movie name is equal to Batman. And of course, this is not a good DB design because you would not want to have the movie name and the data about that movie in this, all these things in one single table. Does that make sense to you guys? You would actually want to normalize it. You would want to have a table which would talk about movie ID and the details about that movie. So let's say movie ID, uske baad hoga movie name, uske baad hoga uski duration, etc., right? So you would want to do that. But here, just to simplify things, I'm assuming that all these things are stored in one single table. Does that make sense to everybody? In a real life scenario, you would want to normalize this across multiple tables. Cool. Now, where movie name is Batman, and let's say the show ID that you're looking for is 1, and let's say the seat number that this particular guy is trying to book for is also 1. Okay, so he's trying to book a seat for show ID 1 and seat number 1 for the movie Batman. Now, this is what how would you go about it? You would select select the row which maps to this particular conditions. You will get a row entry. Now what will you do? Now you will simply check if row entry dot status is exactly equal to empty. Okay, then you can say that I will just make an update query. So update the table name, which is let's say movie bookings, and let's say you would want to set a particular column. What column you would want to set? The status you would now want to make it false so that nobody else can book it, and then you would have to have a where clause, which would be nothing but this entire same where clause. Does this query make sense to you guys? Does this query make sense to you guys? Anybody in the class who is feeling lost out? I hope not, right? This is fairly simple. This is the first thing that you would want to do if you want to build a system like this, right? You would want to get that particular row. You would want to check if the status is empty. If yes, you would say, okay, do the booking. So you would update it, and then you will say, do the booking, and whatever else you want to update, you will update that. Okay, now this is the application code that I have written. Try to understand that this code is going to run at what layer? At what layer is this code going to run? The app server layer. Does that make sense to all of you guys? This is going to run at the app server level, okay? And the data which it is fetching or interacting with is stored at the DB layer. Does that make sense? So you are running a SQL query which is going to run at the DB layer. You get that data, and all these things are going to run at the app server level. Makes sense? Now, can somebody tell me what is the issue with this kind of a query? If you are actually ending up doing this, what is the issue? And I'm pretty sure that most of you would be able to tell me that. Makes sense. I would want more people to reply. The problem is concurrency, right? The problem is concurrency. The problem is that what if multiple users are trying to access the same data point at the same time? Okay. The problem with this kind of approach, as most of you are telling, is the problem is concurrency. What happens? What happens when multiple users are trying to access the same data? Does that make sense? So what happens if you are trying to look at the same data? Cool. Now, how many of you feel that this problem can be solved by using some locks, using some read locks, using some write locks. How many of you feel that this problem can be solved? I would want everybody to reply. So I see three people who say that we can solve it. Sankalp, that makes sense. We are going to discuss that in today's class. Nikhil says, are you talking about row level locks? Let's for now assume, Nikhil, that you are actually taking a lock on a bigger chunk of data, because we are actually going to see issues in taking row level locks going forward. Cool. So almost all of you in the class feel that a lock here is going to solve the problem. A lock or a combination of locks is going to solve a problem here. Does that make sense? Cool. So you can very well have locks at your app server level. Does that make sense? You can very well have the locks at the app server level. But do you understand that there is not one single app server running this? Do you understand that? In a big system like Book My Show, you won't have a single app server which is going to run this. Does that make sense to everybody in the class? I see a lot of you are feeling left out, right? It will not work in a distributed system environment where you have so many app servers. And even if you have an app server level lock at one app server, the problem would be that maybe a different request goes to a different box and you end up accessing the same data. Is that clear to everybody? I hope it is. Now you try to understand. If a lock at the app server level does not make sense, do you see a lock at some other layer making sense? So let me just write one thing here. That one thing that all of us in the class are fine with, we are comfortable with writing, that locks at the app server layer are not going to help. Cool. Now I see several of you replying that yes, that makes sense, that at the app server level you will not be able to have a working lock which is going to solve this problem. Let's have locks at the DB layer. And that makes sense because even if you have DBs, data sharded across multiple DBs, what we discussed was that a particular entry is going to be at one particular box. Does that make sense? This is what we discussed, right? So having a lock at the DB layer is going to solve the problem for us theoretically. Now, just because this is a problem which is going to occur in every single system that you build, and for so many years, for decades, people have been using the relational databases. Almost every relational database in this world comes up with some guarantees for you so that these things can be managed as an abstraction and you need not worry about that. Does the last statement that I made make sense to you guys? Fundamentally, all these things can be made to work using locks at the DB layer. Okay, but relational databases, so your MySQL, your PostgreSQL, your Oracle DB, all these SQL servers, all these SQL DBs come up with some guarantees out of the box. Okay, for you, so that as a developer, you are shielded from having locks at the DB yourself. Does that make sense to everybody in the class? So a normal developer working at any organization need not worry about the locks that he or she has to put at a DB level for relational databases, because this is given to you out of the box. And in today's class, we are going to discuss all these things that comes out of the box in a relational database system. And all these things are going to help you in designing any real life system that you go about in any interview. Does that make sense to you guys? Okay. Now let me tell you one more thing. If you are very, very comfortable with these things, what we are going to discuss today, I can give you a very good guarantee that no matter what kind of a problem it is, even if you try to solve that problem using a SQL DB and doing the sharding and using these things as your background knowledge, the interviewer is not going to reject you just because you did not use a NoSQL DB. Does that make sense to everybody in the class? So it's really in fashion that people or interviewees generally would just jump on to saying that I will just use a NoSQL DB. The problem with saying that is that most of you would not actually have used a NoSQL DB in real life, and your knowledge of a NoSQL DB would be very on the surface, right? Would be very shallow. And the moment you actually go into that zone, you make yourself fall into a trap which you will not be able to come out of. Okay? And even if, no matter how big a problem is, so let me tell you for real, Facebook newsfeed, we must have discussed that already, did we? Or maybe not. Facebook Messenger, we did not. Facebook Messenger actually uses MySQL DBs. And do you guys agree that Facebook is too big a scale to talk about? Facebook essentially is too big a scale to talk about. And even if a system at that scale can run at SQL DBs, no system that you're going to make in an interview is going to you will not be able to say that I cannot make this using a SQL DB just because of this. Does that make sense to everybody? And when we will be actually doing that SQL versus NoSQL class, I would point out to you several examples, several big real life examples, which do not use NoSQL DBs at all. Cool. Uh, does it not depend on the use case? Sankalp, that makes sense. So for specific use cases, a NoSQL DB would make a lot more sense. But my suggestion is that just because you see a problem being very, very big, just because you're seeing a very, very large scale at which you are running a problem, you should not go to the NoSQL way. This is one problem that I see so many interviewees doing. Okay. And even if, on the other hand, if a problem was meant to be meant to be solved using a NoSQL DB, even in that case, if you actually solved it nicely using a SQL DB, having all this information that I'm going to give you today, you are not going to be rejected only because of that. Just get that. Just try to understand it, and I hope that you guys keep this piece of little bit of information with you, so that this is definitely going to help you in your interviews. Cool, makes sense. Now we understand that a lock at the DB layer will solve this problem, but we also understand that there are so many out of the box solutions which can do this for us. Okay, let me take one more example so that things are very much clear to everybody in the class that what is the problem that we are talking about. Okay, so let's assume that there is a counter. Okay, you would have seen this kind of an example before as well, but for the sake of completeness, I would want to discuss it. Okay, Moise has a question. Isn't the choice of SQL versus NoSQL inherent in the type of data we are dealing with? Makes sense. Makes sense. Makes sense. So Moise has a very, very good point. He says that there are some kind of problems which using a SQL would be a very, very overkill. What do we mean by that? So let's try to just try to formulate a problem in which, let's say, you are dealing with huge quantities of data, and the entire data that you have is unstructured. That is, there is no proper structuring in that. So do you understand that any SQL DB would require a structured data? And anybody who's feeling lost out. So we are actually going in multiple directions. Anybody who's feeling lost can really raise his or her hand, and I would be more than happy to answer. So yeah, 3 of you have replied that yes. What about the others? Do you guys understand that in a relational database, this data by definition should be structured, right? Because you actually divide your data amongst tables. Every table consists of multiple columns, and you should have your data which can fill those columns, right? Now, if your problem that you're solving deals with unstructured data, right? There is no structure to the data. So let's try to figure out a NLP problem, natural language processing problem that you're trying to solve. Let's assume you have you want to categorize a particular page. Okay, you want to categorize a particular page. If you want to categorize a particular web page, that whether this web page belongs to cricket or to politics or to finance, now you would have to store the content of the page. Does that make sense? You would have to store the content of the page. The content of the page, you would understand, is going to be unstructured. Does that make sense? You are not going to see that every web page on this world that I am trying to categorize is going to follow this structured ordering. It's not going to be the case, right? Some contents will have 2 paragraphs, some will have 3 paragraphs, some pages will have 1,000 words, some will have 100 words, and so on and so forth, right? In these, and whatever processing that you're doing, in most of the processing, you would either want the entire data together, or you would not want the data at all. Does that make sense? Because you would either want to fetch the entire page ka content कि भाई tell me क्या क्या लिखा था, or you would not want to fetch anything. It would not be the case that you would want to say that, yeah, tell me the content in the second page, fourth line. Does that make sense? Second para, fourth line. That would not be the case. In such scenarios, when you are actually dealing with a kind of a blob data in which you actually take it as a whole or put it as a whole, and there is no inherent structuring, no inherent ordering, no SQL databases there make a lot of sense. Does that make sense? Because there is no inherent mathematical ordering or no inherent mathematical structure. This we are going to discuss a lot more in the class when we actually discuss SQL versus NoSQL. But I hope things make some sense to you guys. Vishali says, but that can still be dumped into some column in a SQL DB2. Is makes sense. Makes sense. So Vishali says you can still actually say that I will just have a JSON and I will just put that JSON in a SQL DB, in one column of a SQL DB. Do you guys agree with that? Can we do that? Can we do that, folks? Yes, we can do that. We can do that. And you would actually see that there are a lot of applications which actually end up doing that. Okay. But the problem is that that is just doing an overkill. Okay. SQL is not meant for things like this. We'll appreciate this when we go ahead, but try to understand that. Okay, so let me tell you a real life example here. Okay, let me tell you a real life example here. One problem that I'm trying to work on right now is that trying to match the correct set of candidates to the most relevant company. Does that make sense? So let's say I know things about Priyanka, Sukanya, and Archit and Lokesh. I know what things they are good at, what things they are bad at, and we know what companies are looking for, what kind of skills. Can we possibly do a better matching rather than asking all of you whether you are interested or not, or rather than just checking your problem solved percentage? Can we come up with a better matching which will match Priyanka to the best job out there for Priyanka, given her skills, right? Now, this is a kind of problem which the data is not going to be very, very structured overall. So let's say I'm actually going to, okay, so I will have to go into a lot of details. So let's not go into all those details, but I would just tell you one thing. So if you are dealing with a big environment in which the data as a whole has some structure to it, and there is a small use case today where it does not have a lot of structure, you would still want to use the same DB and add a column and just put a JSON there. Does that make sense? But if tomorrow this problem that I'm trying to solve, this NLP problem that I'm trying to solve, this machine learning problem that I'm trying to solve is the major problem that I'm trying to solve, I want to optimize myself for this, I would most likely consider going to a NoSQL DB and solving it. Does that make sense to you guys? Cool. So let's come back to the example. Okay. So we have, okay, makes sense, Manish. That's a very valid point. Let's just wait for that particular class. We will be discussing that. Okay, cool. So let's say that there is a counter which is initially 42 or any value. Now let's say there are two users, basically more than one users, who are trying to do some operations on the same counter. Okay, and this is the time at which the operations, this is the time axis at which the operations are being performed. So let's say user one would say that I would want to get the value of X. What value will he get? He will get 42. In the next time clock cycle, he would say that X should be made X plus 1. So that would give him the temporary value of 43. In the next clock cycle, the user can say that I would want to set this value back to the DB, and the value 43 actually gets set to X. Make sense, everybody? Totally makes sense, right? Now let's say at the fourth clock cycle, user 2 comes and he wants to get some data. He runs a get X, he gets 43. Now he runs a X is equal to X plus 1, he gets 44 as a temp value. And now he runs set X, which actually makes 44 being saved to the X, and everybody's happy. There is no issue at all. Okay. Any doubt till this point in time? There is no doubt, right? This is very, very, very simple. Now let's assume something more real life, something more real. मतलब ऐसा तो नहीं होगा ना यार कि दूसरा बंदा इंतजार कर रहा होगा कि कब तेरा काम खत्म हो तब मैं वापस आऊंगा, right? So this will not be the case, right? So In a real life scenario, when you have a big system more where so many people trying to access it at the same time, what will happen? So let's say the user two's job starts actually executing at this time instant, at this particular clock. So you would say a getx, that getx would give you a what will that getx give? People, can you help me with it? So I'm running a getx here. It will give me a 42, right? So it will give me a 42 because at this point in time, the value at x is 42. And then it will say x is equal to x plus 1, which will make a temp value of 43. And then it will do a set x and it will set 43 to x. Do you guys see a problem when these two things happen together? This problem is a very, very generic problem, and we call this problem the problem of a lost update. Does that make sense? So there was a update. There were two updates that you wanted to do. Ideally, you should see a value 44 after both these things were done, but there is a lost update that happened and your value at the end is still 43. This is one problem that you would see all the time if multiple things happen at the same time. Now, let me ask you one thing. Do you think this problem would occur if the DB was a single threaded DB? Let's say if my box is a single threaded box. Do you think this problem will occur? This problem will not occur, right? Because at any given point in time, there is only one clock cycle that is being done at the DB level. If it was one single threaded box, nothing of this sort will happen. But do you think is that a solution? Can I just go on and make my DB boxes single threaded? Of course not. Of course not. That would increase the turnaround time. That would increase the latency. बहुत ज़्यादा, ठीक है? So that's not what the solution that we are looking for. Okay. How is a thread linked to cycle? Please explain. Okay, Sankalp. So do you understand that any sequence of operations in a computer are actually performed at clocks? Have you maybe done a course on computer architecture in your college? So you would have seen that every operation runs at a clock. मतलब एक clock चल रही होती. There is a clock going on in a computer, and every new operation, atomic operation, happens at a new clock. Now, if there is only one thread which is executing some things, you would agree with me that at any given clock, there is only going to be one operation which is being performed. Does that make sense? Right. And then if you say that I am actually going to perform only this operation and only everything else will be queued before this operation, this bigger level operation is done, then it would not be an issue. Okay. But the problem here is even more deeper. The problem here is that these operations together, even if at the application level, you may see that these operations are atomic, but at the execution level, these operations may not be atomic. Does that make sense to you guys somewhat? So when these operations are not atomic, then you would see even at a single threaded application, you would still have problems if these can be interleaved amongst each other. Does that make sense to you guys? Actually, we are going into a bit more depth, which is not required, but I hope it makes sense. Cool. Let's actually move ahead. Now, knowing what a SQL DB does. So let's say, So let's assume that we were performing these operations in a normal SQL DB. Would you tell me what kind of a SQL query will this be mapped to? GetX? What kind of a SQL query would this be? This would be a select query. How many of you agree with me? This would be a select query, right? This second operation is not a SQL operation as such. This is a mathematical operation that you are performing at the app level. Now, this third operation that you're doing, can you tell me what operation this is? This is update. Cool. Now, let me tell you one thing here. For all the SQL DBs that you see, any single operation, any single select or update, or any single select or update that you're doing, or delete or create that you're doing, even when it is compromising of multiple atomic instructions, the DB gives you a guarantee that that particular thing, select statement, is going to be performed atomically. Does that make sense? So it's not going to be the case that you are doing a select And before, so it's not going to be the case that the select is going to stop midway. Does that make some sense? So one very simple way to solve this problem would be, I would just mention it, but that's not a very good solution. That's a very bad solution. But I would just give you one simple way around of this. One solution here to solve this counter problem would be that you simply call a statement update. Let's say you call the statement update counter table, and you want to set the counter is equal to counter plus 1. Do you see what we are doing here? Just in one statement, I am performing all these three tasks together. Fundamentally, at the clock cycle level, these things will not be a single operation, but still, out of the box, MySQL will give you a guarantee that this thing will occur completely before anything else can occur on this particular data. Do you see what is happening here? Vishali, you cannot. Vishali, is there any issue? This won't occur in one cycle, Moez, of course not. This is just a kind of just a kind of abstraction that the DB is trying to provide to you. Does that make sense, Moez? Okay. Vishali, let me just try to explain it to you once again. Or let's do one thing. Let's just forget about this for the moment, because this is not a good solution. This is just kind of a hack. I would try to explain this hack at the end of the lecture, Vishali. Just keep this in mind. You can just remind me if I forget. I will just come back to it and explain it at the end of the lecture. Let's actually discuss things conceptually first of all. Not a very good place to start. Okay, this hack here. Anybody else who's feeling lost? Anybody else who's feeling lost? Guys, do you understand what we are discussing till this point in time? I hope everything is clear, right? Everything is clear, right? Cool. If there is anybody, do not wait for the class to end and then let me know कि यार मेरे को समझ नहीं आया. Let me know right away. Cool. I hope this is very clear to everybody. Now, to solve this and so many problems that come with DB, the problem of concurrency, we are going to discuss this entire class today. And let me tell you all these things one by one. Okay. The very first concept that you see in a relational database, or this is not only specific to relational database, this is a theoretical concept, but relational databases give you that kind of a guarantee. The very first thing that we see is transactions. Okay. What is a transaction? Transaction is nothing but you grouping together multiple queries in one group. Does it make sense, folks? So transaction in definition is nothing, but you are saying that I actually want a set of queries to be run, but I would just group those queries into one transaction. Does that make sense to you guys? Now, whatever we are going to discuss in this lecture going forward is going to assume this definition of transaction. So what do I mean? Let me just explain it to you once again. So let's say you have a select query, you have some computation, and then you have some update query. All these things together make sense as a single piece of code, or let's say make sense as a single combined operation. Does that make sense? Given your application, given the thing that your application is trying to do, all these things make sense together. So to try to form a wrapper around these queries, we call these things a transaction, and we can define transactions in our DB. Okay. Basically, we can define a set of instructions as one transaction, and then with the transaction, there come some guarantees. Okay. Now let's try to see what guarantees come in with any relational database. Okay. It's an abstraction. Sankalp, you're absolutely right. fundamentally it still compromises of multiple statements. And appreciate that fundamentally every statement compromises of multiple instructions. Okay, one abstraction that the DB server does for you itself is that it will tell you that all the multiple instructions that were there in this select statement, I am grouping together all these things for you in one SQL query. People, is it making some sense? So one abstraction that the DB does automatically for you, that all the fundamental operations that are happening, it will group them for you and tell you that this is one kind of a SQL query that you can perform, a select query. Now, for applications that you try to build, for complex applications that you try to build, that is not enough. You would want some more kind of abstraction, some more kind of a wrapper around things. And that is when DBs allow you to define transactions. Cool. Now, every transaction comes with 4 properties in a relational database. These properties are theoretical, but no SQL database do not come with these properties in general. And these properties, as some of you are already pointing out, are the ACID properties. Folks, let me tell you one thing. No matter how many times you have heard this word ACID properties, do not just assume that the next 10 minutes of this class are useless to you. Okay? I have seen so many people who actually just know the full form of these 4 terms, but nothing beyond that. And that is something which is not going to help you in any interview. Okay? This is something which is a must if you are looking for a software engineering role. And I cannot impress upon you how important this is if you're looking for a SD2 role. Okay? Cool. So, ACID properties come with transactions in a relational database. The properties are as follows. First of all, I will tell you the property A. A basically means atomicity. Okay. What is meant by atomicity? Atomicity means everything or nothing. What does that mean? That means if you have defined a transaction, okay, either everything will run or nothing will run. Does that make sense to you guys? Either everything will run or nothing will run. Now you will say, bhai, ye kaisi baat hui? Ye to hona hi tha. But that's not the case fundamentally. If you're looking for a real life system, just because a particular select statement is compromising on multiple fundamental statements, and leave over the transaction compromises on multiple SQL queries. Now, what can happen? If you're performing a transaction, what can happen? You can say that maybe the DB went bad, the box was set on fire, or let's say maybe the electricity went down, or let's say there was some issue in the box, there was some network problem, and so on and so forth. Do you guys understand that there are so many things that can happen while you are in between a transaction? Okay, and not even in between a transaction, in fact even in between a particular statement as well. So let's say you are doing a select, and select would not be a single unitary one clock statement, right? Select ke liye kya karna padega? You will have to transact, you will have to travel the entire database, do some kinds of checks, and so on and so forth. It can very well happen yaar beech mein koi dikkat ho gayi. So you would not want to be in a state when only a partial statement, or in fact even some statements of a transaction are done and some are not. So atomicity basically means that your transaction is always going to be everything or nothing. So either I will say that your transaction was done completely, or I will say, man, something went wrong, nothing was done. Okay? So do not assume that some things were done and then something went bad. I am giving you a promise that nothing was done. Is everybody in the class crystal clear with atomicity now? Would you ever make any error in discussing atomicity with any interviewer? Because the moment you do it, you are out of the interview. Okay. Can we assume that all the operations in a transaction reside in the same DB shard for this rule to hold true? A very good point Beshali has raised. So let me just try to drop one more bomb out here. So by definition, so recently things have changed, but let's not discuss that. By definition, relational databases were meant to be running on a single box. Okay. So all the kind of things that we see here would actually be uh, automatically valid if everything was on a single box. Do you guys appreciate that? So Vishal is absolutely right. So if you were doing vertical scaling, what is vertical scaling? You can see okay, so let's even not go to vertical scaling. Let's assume every data was based on a single box. Then the SQL server that you are using would give you these guarantees out of the box कि भाई सब कुछ इसी बॉक्स में है, मैं सब कुछ संभाल लूंगा, चिंता मत करो, ठीक है. But now as data grow and we want to use MySQL or SQL boxes still when we actually cannot fit the things on one single box and they actually spread across boxes, then the problem is that your transactions are not only happening on a single box. So recently, these servers do provide you with some support to distribution, some support to sharding. But for now, assume that anything when once goes to a multiple boxes, you will have to do some things from your end over and above the things that come out of the box. Do you guys appreciate it? So whenever you are saying that the data was sharded across multiple boxes, keep in mind that you will have to do something from your end and you cannot expect everything out of the box. Okay. We will discuss some things out of it in this curriculum. We will leave out something else because that will make this maybe 4 or 5 weeks curriculum, which is not practically possible. So, and maybe we would try to discuss some things once we actually go to the backend track. And if I am taking your classes, we will try to discuss some things there as well. But for now, let me take a call what all is important or not. But you guys appreciate that the moment your data is sharded across multiple boxes, do not assume all these things to be happening automatically. You will have to do some things from your end. Cool. Now let's move ahead. So atomicity should be clear to everybody in the class. Let's now discuss consistency. Now here again, I see a lot of, not in today's class, Sankalp, for sure, maybe sometime in the future, most likely not even in this week, because we have a lot of things to cover and I need to prioritize some things. But maybe after a couple of weeks, we can take a few more classes if you guys want to, and maybe then I can discuss that. But yes, we will remain in constant touch and we will take a decision collectively, and let's not worry about anything. Okay, Sankalp? Cool. Okay. So the second thing in this asset property is called as consistency. Okay. So consistency basically means not the cap theorem wala consistency. Okay. So let me actually tell you one more thing for okay. So atomicity was done. There is no doubt for atomicity, right? Do you want me to give you some examples for atomicity here? There is no doubt for atomicity, right? Okay, cool. Let's move to consistency. Consistency here basically means, do you guys know about that relational databases allows you to add some constraints? Do you guys know that? So let's say you are defining a table. You can have a constraint that maybe this column will only have unique values. Have you seen these kind of constraints? Or let's say you can say that this particular column, any entry cannot have a null value in this column, right? Not null. So databases allows you RDBMS allows you to have some constraints. What kind of constraints? So let's say, as you guys told me, कि यार unique होना चाहिए, or you can say not null, things should not be null in this particular row, or what else? Or you can have some kind of cascades. Okay, so this is one. You can have some constraints. Now let's say you can have some cascades. What does that mean? Before cascades, do you know that you can actually have foreign key constraints? Do you understand that? So you can have foreign key constraints. What is a foreign key constraint? So let me just explain that to you in brief. So let's assume there are multiple tables, right? So there is one table which talks about movie ID, comma movie name, comma movie duration. Okay. So let me just mention that. So let's say there is one table which talks about movie ID, movie name, movie duration. This is one table. Okay. Now let's assume there is another table as we discussed, जिसमें अपने पास होगा movie bookings. Now in movie bookings table, you're going to have a movie ID. You're going to have a show ID. You're going to have seat IDs, and you're going to have status. Does that make sense, everybody? Now, foreign key constraints here means that you know that this movie ID is not different from this movie ID. Does that make sense? Another thing that makes sense is कि if I only have movie ID 101, 102, 103 here, can I actually add a row here which says कि यार movie ID 107 का तो ये show लगा हुआ है इधर देख के आऊंगा. You cannot say that, right? Because there is no movie which actually exists with 107 ID. So you understand that there is a foreign key constraint here. And these kind of constraints are also what DBs allows you to do. Now, what is cascades? Cascades basically means that let's say there was a 107 before, and now let's say मेरा झगड़ा हो गया उस मूवी के मालिक से, प्रोड्यूसर से झगड़ा हो गया और मैं नहीं दिखा सकता उसकी मूवी अब, ठीक है, अब मैं नहीं दिखा सकता या फिर मैं नहीं दिखाना चाहता, मैं यार बहुत नाराज हो गया हूँ, मैं कहता हूँ यार मैं तेरी मूवी नहीं दिखाऊंगा, मैं कट्टा हूँ तुझसे. So what will happen then? Okay, so if I just remove this entry here, you guys will agree that there should be, just because you would want to have consistency maintained, you would want to have cascade deletes, right? So you would want to cascade this delete, matlab you would want to carry forward this delete with all the tables which were actually dependent on the same movie ID. So you will want to remove all the rows which are talking about 107. Does that make sense to everybody? Okay, so DBs also allows you to do cascades, okay, and triggers and so on and so forth. So these kind of things, triggers, cascades, constraints, foreign key constraints, all these things DBs allow you, okay. Now, consistency basically means that whenever you are doing any operation, the DB will make sure automatically out of the box ki whether that operation is leaving your database in a consistent state or not. No, Nikhil, there are several kinds of cascades and we will discuss those when we actually discuss the DBMS lectures. Have we had the DBMS lectures? No, we have not, right? So let's wait for the DBMS lectures. In those, we have already had those lectures. Okay. Okay. Did we discuss this there? We did not. Deepika says we did. Sukanya says we did not. We should have discussed this. Manu says we did not. Okay. Oh, some of you are saying that we did. Some of you are saying that we did not. This is strange. Okay, we did not. Okay. If Nihal took it and we did not, so I will just maybe go through that lectures once, and if required, we can have a follow-up class for DBMS. Okay, cool. So let's not do too much of digression here, but try to understand that all databases का asset में C का मतलब है कि your data will be consistent. Does that make sense? So database will out of the box ensure, okay, out of the box DB will ensure that these constraints are honored. This is the second property that comes out of the box with almost every relational database, okay, or the C in the fundamental asset properties. Cool. Now let's come to, okay, so we have discussed A, we have discussed C. Let's not come to I first of all, let's come to D because that is simpler. So let's discuss durability. Okay, now what is durability? Durability basically talks about the basic quality of any database, which talks about persistence. Vishal, you're absolutely right. Durability basically means कि whatever data that you are writing in a DB, whatever changes that you are making in a DB would remain there unless and until somebody actually updates it. Okay, so whatever changes that you are making will remain there till the end of time. Okay, whatever whatever changes that you're making will remain there till end of time unless and until you specifically update them. Does that make sense to everybody? This is a very, very fundamental property for any database because databases are used for persisting data, and it should not be the case कि यार मैंने भी आज कुछ write किया कल आके देखा कि DB का मन नहीं है and that write just went away, right? That should not be the case. Okay. Now I am pretty sure that none of you would be assuming that to be the case, but let me just tell you for the sake of clarity. This does not mean कि it will remain till end of the time. Guarantee दे दिया तो guarantee दे दिया है. But what if you put your box on fire? Right? If you put your box on fire, DB guarantee of durability would not come in handy. Durability simply means that if the box is running up and running, you would for sure always have that update persisted there. Cool. So we have discussed durability as well. Now let's come to it's not the case it's not the case that you bought a DB from Oracle. You bought a license from Oracle and you said, hey man, up to you have given me a durability guarantee. Whatever happens, I will just put this box on a fire, but still the data should be there. It would not be there, right? Cool. Now let's actually come to the last point, which actually is a very, 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 very detailed topic to be discussed. And that talks about the I in ACID, which talks about isolation. Okay. Now, what is isolation? Before coming to what is isolation, let's actually maybe take some examples. Okay, cool. Or let me actually tell you one thing. Isolation. No, it's not integrity, Sukanya. It's isolation. Okay. So what's isolation? Isolation basically means that you are performing a lot of transactions simultaneously on one DB. Does that make sense? So you are performing a lot of transactions on one DB simultaneously. Isolation basically means that these transactions should have some sort of isolation amongst themselves so that it does not happen that just because one transaction was running, it does some unrequired changes or unthought of changes for the other transaction. Does that make some sense? Folks, does that make some sense? Waiting for you guys to reply. So isolation basically means just because you are going to have multiple transactions running at the same time, isolation basically means that you would agree to me that there is some sort of requirement for these transactions to behave as if these were behaving isolatedly on the same data so that they do not cause issues for the other transactions. One option that we just saw here when we were updating the counter, do you see this is a problem of isolation? No, it's not atomic. It's not about atomicity. So people, this is again a very, very common doubt that I see multiple times coming up. People tend to say that isolation is nothing but atomicity. How many of you feel that isolation is nothing but atomicity? How many of you are, even though everybody knows that that's not the answer, but I would still want to understand that how many of you feel that it's similar, it's same, there should not be much difference. We're talking about the same thing. Okay, they're not similar. They're absolutely not similar. Let me tell you how. Atomicity simply means everything or nothing. Does that make sense? Atomicity simply means that a transaction will either run completely or will not run at all. Did I ever make any comment when I was discussing atomicity about how multiple transactions are going to perform simultaneously? No. So atomicity does not deal at all with multiple transactions working at the same time. Atomicity simply means that one transaction I am giving you a guarantee will either get completed or will not get completed at all. Does that make sense? Cool. If it makes sense, let me actually now try to tell you what isolation is. Okay. Or in fact, that I will. There is one more thing that I want to discuss about atomicity, but let's just wait for a while. I will discuss that. Isolation basically means that there should be some sort of rules for multiple transactions to be executing at the same time. Does it make sense? There should be some sort of rules. You realize that there is a requirement for some sort of rules. Okay. Now, you tell me if there were multiple transactions that were running simultaneously, but on different tables altogether. Do you think there would be any issue? Or let's say different data points altogether. There would not be an issue, right? If there was no common data amongst different transactions, तब isolation automatically है क्योंकि working on isolated chunks of data. But you would agree that in real life scenarios, that would not be the case, right? Because relational databases are always related. So even if you're making a change in one table, there may be something else that may be changed in the other table. Does that make sense? I will give you examples in this class where even if you're updating one row and there was a different transaction working on some other row, you can still have some problems. I will give you some example. Of course, that's not the correct statement to make. There is, of course, there was some kind of a what do I call it? Common data. Only then the issue will arise. But the point is, it's not only about that you are writing to the same row, right? It's much more than that, and we will try to explain it. Okay. So isolation basically means that you would want to, if multiple transactions are trying to update या फिर more generically work on same data, you require some set of rules plus guarantees from your DB. And this is what we saw in the book my trip example, book my show example, and we also saw that in the counter example, right? And we will see that we can actually come up with so many examples in this world which would realize, in which you would realize that isolation plays a very, very important role. Cool. Now, isolation basically determines how the transaction integrity is visible to other system, other users and other transactions. What does it mean? What kind of a isolation you have will determine that what kind of a visibility one transaction has over the other transaction. Does that make some sense? We will try to build it more going forward. Okay. So basically, there are a few contracts that you see in transactions. There are some isolation levels. Sankalp is absolutely right. So there are some isolation levels. Okay. There essentially are 7, 8. There are so many different isolation levels, and we will at the end try to explain you. I will try to explain you why it's nothing more than just giving names. But we are actually going to discuss 4 or 5 in today's class, and everything else, if you want, you can read up yourself, and everything will make sense because we are going to discuss the 4 or 5 most fundamental isolation levels. Okay. So one very, very basic isolation level is read uncommitted. Okay. Bishali, just hold on for a while. You will understand it automatically. Okay. The second kind of isolation level that I would want to discuss today is read committed. Then you have an isolation level called as snapshot. And then you have an isolation level called as serializable. I would most likely also discuss, if time permits, repeated reads. Okay. So I would also most likely discuss repeated reads. Repeatable read, it's what that is called. Repeatable read. Most likely to discuss that. Good. Now the point is, these isolation levels are basically some set of rules or some set of guarantees that the DB is going to give you. Okay. The guarantees increase as you move down. Okay. So you see more and more stronger guarantees as you move down. Does that make sense? You see stronger and stronger guarantees as you move down. The second thing is, it also becomes slower and slower as you move down. Does that make sense? And which is only fair, because system design is all about trade-offs. And here you are actually going to see a trade-off between more strict rules versus speed. Does that make sense to everybody? And do you also appreciate that just because you are actually having more strict rules, that only means that you are actually having more set of locks that you are using. And the more locks you use, the less is the parallelization possible. And the less is the parallelization possible, the slower would be, the more would be the slower would, the more would be the latency, and the more slower would be the speed. Does that make sense to everybody? Fundamentally, it's nothing but having more kinds of more and more locks as you move down these levels of isolation. Cool. Let's actually start discussing them one by one. I will first of all discuss the read uncommitted. Before actually coming to discussing this, I think it's now the best time to discuss how states in a DB are maintained, and which would also explain to us how atomicity is performed. Can somebody take a guess that how atomicity is ensured? What was atomicity? That either everything will happen or nothing will happen. Can anybody take a guess how atomicity is maintained? Okay. How lock would enable an atomicity? Moise and Sukanya say locks. How Moise, would you want to explain how a lock would be helpful in maintaining atomicity? Sankalp says transaction. Sankalp, transaction is just a word that you use for a group of statements. Transaction in itself is not anything, right? Manish here is absolutely right. Manish, Sohail, Sukanya, you are absolutely right. You guys are saying that you would want to commit and roll back. Okay, now let me explain to you in very, very great detail how these things happen and how this allows you to give atomicity. Okay, whenever you are running a transaction, you would first of all be at the begin state. Does it make sense? You actually just, let's not even call it a state. Let's say you are just beginning your transaction. Whenever you begin your transaction, the first state that any transaction goes to is the active state. That is, transaction is active. Now when it starts, now you agree that a transaction is built of multiple statements. Does that make sense? A transaction is built of multiple statements. Now, when it starts executing a statement and the first statement executes, you would agree with me that this, now it's not at the beginning state, it has done something. So there should be a different state to represent it, and that state is called as partially committed. That some parts of that statement are done, that transaction are done. So let's say select, update, select, update, select, update. It was a big transaction. Let me tell you an example. Let me give you an example. Let's assume there was a guy A who wanted to move 500 rupees to a guy B. Okay, you are actually using Google Pay. Let's say you want to send 500 rupees to B. Or let's say you are actually at a bank, you want to transfer 500 rupees to a friend of yours. Can you tell me what kinds of operations are going to be performed? And I would want the exhaustive list of operations, everybody. First of all, you would want to select from A. You want to figure out how much money he has. Does that make sense? Once you select it, you would want to have some check कि भाई उसके 500 रुपए है भी कि ऐसे ही टाइम पास कर रहा है हमारा. ठीक है. उसके बाद what would I want to do? Then I would want to update the balance of A, and I would want to say A dot bal is equal to A dot bal minus 500. Then I would want to check how much money does B have. Why do I want to check that? Maybe there is an upper limit. Maybe B has stored tens of crores of rupees in that account, and now the government is feeling कि यार और तो नहीं डालने देते और 500 रुपए रोकना चाहते हैं हम डालना. ठीक है. So you select whether that particular account has hit that maximum limit or not. Okay. Then you actually check it again and then you update it. Does that make sense to everybody? These are the things that you actually see, multiple statements that you actually see in this transaction. Do you agree that all these things should be part of one transaction? This is one option. The second option is that maybe these things should be part of one transaction. These should be part of some second transaction. Or the other option is that this entire thing should be one transaction. Or yeah, this should be one transaction, right? This should be one transaction. The point is कि it should not be the case कि यार A के पैसे से तो 500 रुपए चले गए, B को मिले नहीं और मैंने अपनी जेब में रख लिए. I am running a very good bank. A wants me to transfer 500 rupees to B. उसके अकाउंट से मैंने डिडक्ट कर लिए. अब B में नहीं हो पाया, मेरा सिस्टम फेल हो गया. क्या करे, गरीब आदमी है. 500 रुपए रख लिया. उस 500 रुपए रख के अच्छे इंजीनियर हायर कर लेंगे जो कि सिस्टम बेटर कर देंगे. ठीक है. तो ये assume कर लेते हैं, but that's not correct, right? So you would want to have all these things in a transaction so that either everything runs or nothing runs, right? So all of these things should be as a part of transaction. In fact, what do? We actually call this thing as T1, transaction 1. We call this thing as T2, and we say that there is a transaction 3, which is nothing but T1 plus T2. Does that make sense? So you can have levels of transaction. You can say that there is a transaction T3 which contains these two transactions, and now just because there is a bigger transaction T3, all these things would either execute, these would execute atomically. Either they will execute completely or they will not execute पूरी तरह से, ठीक है? So now why did I come to it? I come to it because from active, the moment, let's say, this first statement is computed, you will actually go to the partially committed state. Does that make sense? And now you will keep on in this partially committed state unless and until all the transactions are completed. There are two options here, folks. One option is that all the transactions will get completed completely, and now from partially committed, your state can actually move to committed. Does that make sense to everybody? There are two options here. One option is कि सब कुछ हो गया पूरी तरह से. The second option that you have is something failed, and you now actually go to the failed state. Does that make sense? In fact, even from the active state, there were two options. Either the first statement will get executed or it will not get executed. If it does not get executed, you can directly move from the active to the failed state. Okay. Now what happens? Once you are at the failed state, now you will have to abort here and say, hey man, मैं नहीं कुछ कर पा रहा. Does it make sense? And whatever partially committed things that you did in this abort state, you will have to uncommit all of those. Does that make sense? In this abort state, you will have to roll back all the partially committed things that you did. Does that make sense to everybody? Does that make sense to everybody? And now from this abort state or from this committed state, there is only one way to go, and that would be the end. Does that make sense? Does this flow make sense? And does this now explain to you guys that how atomicity can be maintained in a DB? Just because a particular transaction goes through all these possibilities, that is how you can maintain atomicity here. Cool. Now, why did I come to this right now? I come to this right now because now I want to discuss these isolation levels, and understanding about these states will allow me to discuss these isolation levels better. Okay. How many of you are till this point in time finding this class useless and boring? How many of you are feeling that this is not helping you? Anybody who's feeling that? Okay. 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 What about the others? You guys are getting something out of it, right? The reason for having this class is because this is going to help a lot of you in your interviews for sure. This is expected out of you. If somebody does not ask you in this interview, this is only because he or she feels कि ये तो आता ही होगा. But the moment somebody realizes कि ये नहीं आता, you are straight away rejected. Okay. So this is very, very important for any backend engineer out there in this world. Okay, cool. So we understand this. Now let's come to those isolation levels again. Okay, will transactions be in active state if we don't use the end? I did not get your statement, Sukanya. Sorry, Neeraj, I did not get your statement. Neeraj, I did not understand the statement. Sukanya is asking, how will they ask this question directly? Sukanya, they can very well ask this question directly. So what happens in here in interview bit, when somebody is interviewing at interview bit, we ask them to actually design a DB schema for a problem that we are trying to solve. And then we try to probe them that how would these things happen? Let's say that how would this kind of a thing be happening at the DB level? And these things you will only be able to explain once you know all these things. Does that make sense? Okay. Now, Neeraj, do you want me to unmute you? Is there anybody who wants me to unmute you? Okay. Once they asked me, how will you manage atomicity in a distributed system? Okay, makes sense. So that's out of the scope of today's class, Lokesh. But remind me, most likely, whenever we are actually discussing SQL versus NoSQL, you can just remind me then. I will just write it so that I also remember that we need to discuss this. But this is a very, very interesting question. Which company did you were asked this, Lokesh? Arcesium. What did you reply? Do you want to share what did you reply? Okay, not an issue. Cool. Let's now move ahead to the first isolation level. The first isolation level that we wanted to discuss was read uncommitted. Not an issue, not an issue, Lokesh. Did you manage to clear the interview? Makes sense, Sukanya? But it's very, very important that you know all these concepts together because these are very, very important. Okay, cool. Now let's come to read uncommitted. Uncommitted basically means that there are no guarantees. Okay, there are no guarantees whatsoever. There is a transaction happening, it will begin. मतलब the other guarantees for asset में जैसे atomicity, consistency, durability, these guarantees are there. I am specifically talking about the I. Do you guys realize that I am specifically talking about the I here? Does that make sense? As asset में atomicity, consistency, durability will always be there with transactions. I am discussing the I here and different levels of isolation. So the first level, the very, very basic level of isolation is called as read uncommitted. In this transaction, you may even read uncommitted changes. I will explain this. In the meanwhile, let me read what Lokesh says. Yes, till the right, I told that I have not worked on distributed OS, so I explained the simple system. Makes sense, Lokesh, and congratulations if you managed to clear that. Very, very happy to hear that. Cool. So read uncommitted. Read uncommitted basically means no guarantees. This is the lowest level of isolation level. Okay. Now, this, as the name suggests, allows you to read uncommitted data. What does that mean? So do you understand that these are the states? So even when the state is not at the committed, it's at some other state, even then you can read it. What does it mean in a more detailed fashion? It means that let's say there is one transaction which is doing some writes and that transaction has not reached the committed state, and some other transaction comes and it wants to read some data. It will allow the transaction 2 to read the uncommitted data as well. Does that make sense to everybody? I will be coming to dirty reads at the end of this lecture. Do not worry about it right now. So in this, I am even allowing a transaction to read uncommitted data of some other transaction. Okay. If transaction fails, I did not get, if transaction fails, makes sense. Exactly. So I will discuss what's the issue there, Nikhil. But this is the lowest level of isolation. In fact, in this level, transactions are not isolated at all. Okay. Transactions are not isolated from each other. Now let me try to give you an example which we are going to use again and again in this class, which explains everything to us. Okay. So let's assume there is a piece of data sitting in this DB. There is a user 1, there is a user 2. Okay. And that piece of data, there is a timeline, right? This is real time, physical time. Okay. Now what happens? Let's say this is a piece of data called X. And let's say the value of X at the beginning was 2. Now this user wants to read that value. So what will it do? It will send a GET request. What is a GET request? It's a select request. Does that make sense, folks? So this user will send a GET request for GetX. This request will take some time to process. Does it make sense? It will take some time to process. And then it will reply back to this user by saying that, hey man, the value of X is 2. Does that make sense? Now, let's say user 2 also wants to do something, because if it does not do anything, then the problem will be very, very boring. User 2 also wants to do something, and he will say that, hey man, I want to set a value of X. Okay. Now he wants to set a value of X. He wants to set value of X at equal to 3. It will take some time to process, and then the user will be told that, hey man, okay, I just performed your value. But understand that this user was not running a single operation. This user was running a transaction. Folks, does it make sense? Let's assume these users were running a transaction. A transaction can have more than one statements, right? So let's say this user was running a transaction. This, let's call this transaction 1. Okay, the first operation in this transaction 1 was this, and this, let's assume this user is also running a transaction, and his transaction starts from here and ends at here. Folks, does it make sense? Or let me actually just maybe take a smaller transaction this time around. So let me say this transaction starts from here and ends here. Starts from here and let's say ends here. Folks, are you getting something? This is transaction 2. This is transaction 1. In this user, for which there is a transaction 2, he performed this get x here, and let's say now he performed another get x here. So he said कि भाई मेरे को x की value बता दो. उसने बता दी कि भाई x की value 3 है. Does that make sense? Why this value of x equal to 3 here? Folks, does it make sense? Because the other user used this set x before. This is not get x. This is actually set x. And now this transaction ended. The transaction 2 for user ended. And let's say for the user 1, the transaction 1 was not only of this statement, but there was another statement. So that user wanted to do something else here as well. And then the transaction ended. Folks, does it make sense? Do you guys see a problem here? The problem here is that what happens if there was, let's say there was an issue after this statement at this point in time. What will happen if there was an issue here? If there was an issue here, do you guys appreciate that transaction 1 will have to be rolled back? Folks, do you understand it? Transaction 1 will have to be rolled back. और for the user 2, उसका बुरा कट गया है. उसको बता दिया कि भाई x की वैल्यू 3 हो चुकी है. वो अपना आराम से धंधा कर रहा है कि भाई x की वैल्यू 3 हो चुकी है. अब वो बेचारा, उसको पता ही नहीं कि वो तो ट्रांजैक्शन कैंसिल हो गई. राइट? तो यूजर 2 के साथ अन्याय हो गया इधर. राइट? क्यों? he actually read some uncommitted data. Does it make sense? So this is what is the basic problem with this kind of isolation level, in which you see you are reading uncommitted data. I am not reading, appreciate. There are a lot of folks which actually make this kind of a mistake. They say कि यार, they feel कि problem ये हो रही होगी कि पहले user ने ये करा, दूसरे user ने ये कर दिया. This is not the problem, folks. This is not the problem. The point is that a single, and Bishali, this actually takes me to what I wanted to discuss at the beginning of the lecture, but I wanted to come back at the end. I will still come back to it at the end, but let me just explain to you that in SQL, and everybody please try to make sense out of it if you guys can, in these relational databases, whatever single select statement that you are doing, irrespective of if it being compromising of multiple smaller statements in itself, every single statement is a transaction in itself. Does that make sense? And every single statement will give you that guarantee कि भाई मैं पूरी तरह से हो जाऊंगी, and मैं अपने बीच में किसी और को तंग नहीं करने दूंगी. Does that make sense? So every single statement that you perform is going to take some kind of a lock, so that that statement can be performed without anybody else interrupting in between. So this kind of a thing you will not see here. Folks, does it make sense? And can you guys make me happy by some of you telling me that you thought that this was possible? I am pretty sure that some of you would have thought that this was possible, because I have seen so many people actually in this thing of read uncommitted actually drawing diagrams like this. Does it make sense to you guys? So it's just levels of abstraction. a single SQL statement in itself is a transaction, is itself is an abstracted thing, but we are trying to actually build multiple statements in one and call it a transaction and give some guarantees out of it. Does it make sense to you guys, what I just said? Okay, cool. I hope it makes sense, right? If there is anybody to whom it does not make sense, it's your responsibility to let me know. I would be more than happy to help you. So we discussed this. This is a big problem here. So read uncommitted is a very basic level of isolation in which there is no isolation. Okay. Now the problem. Now some of you would ask that if this is this bad. Okay. Okay. Let me now tell you one more thing. So actually, when you are running a SQL server, SQL DB, you have to specify what isolation level your system is running at. Do you appreciate that? You have to specify what isolation level a particular system is running at. Do you guys appreciate that? Now Sankalp is asking default is read committed. The point is there are different defaults for different systems. So let's say maybe MySQL will have a different default. A PostgreSQL will have a different default. Okay, cool. Now Sanket wants me to repeat something. Sanket, do you want me to unmute you so that you can explain to me what you want me to repeat and I can repeat it? For sure, Vaishali, I can also unmute you. Sankalp, do you want me to unmute you? Oh, sorry, Sanket, do you want me to unmute you? Okay, last part, single transaction. So the diagram that I just drew, is that what you guys are? Okay, Vaishali, is that also your doubt? Okay. Vaishali, do you want me to unmute you?
Hello.
Yeah, Vaishali.
Yeah. That last diagram that you did, I actually thought that overlap is possible. So
okay, just a minute.
In the select use.
Okay, the point here is कि, let's come back to the statement that we made before, the counter wala thing that we made before, right? So I told you that if you are actually doing a select, everybody in the class, please appreciate what I'm just saying. So I told you if you're doing a select statement and update statement, and there were two users performing this at the same time, making the counter increment by 1, there is a possibility that there is a lost update. Is everybody clear with that?
Yes.
Is everybody clear with that? Vishali, are you clear with that?
Yeah.
One possible solution that I told at that point in time, but I did not follow through, was this. If you remove that select statement and only have one update statement, which goes something like this, saying update counter table, set counter is equal to counter plus 1. Do you guys see what I'm doing here? I just somehow merged those two statements, one select plus one update, into one update statement. Do you guys see that?
Yeah.
And now my claim is, if you are doing this statement, this problem will not exist. If you are running this statement twice, once from user 1 and one from user 2, you will always get 44 as the value and you will not have a lost update problem. Do you guys understand? Do you guys do not worry about agreeing to that statement? Do you guys just understand what I just said? If you just boil it down to one statement, that problem will not exist. Now, Vaishali, to explain that, this is what the diagram that I just drew. To explain this can only be explained if one single statement is making sure that nobody else is going to come in its way and do something funny.
Okay.
Vishali, does it make sense?
Right. So you're basically saying that when my select is executing, which means nothing can update.
Right. So nobody else can actually update the same kind of same statement because there is a select statement running on it.
Okay, got it. So that overlap
problem in itself, but this is not a solution for everything, right? This was possible here because I was just doing a counter plus 1. But what if I was actually doing some sort of operations in between? It was not possible to combine it into one single update. Okay? I'm not talking about running a complicated query. I'm not talking about running a complex query. A complex query can be made of multiple statements. That will not solve the problem for you. The thing that will solve the problem for you, you can just have one single statement. Does it make sense? But that is not going to be always possible. That is why you actually define transactions. And once you define transactions, you talk about different isolation levels. Does that make sense, Vaishali?
Yeah. Thank you.
Thanks a lot. Does that make sense to everybody else in the class as well? Cool. Let's now move ahead. So we discussed the first kind of isolation level. Let's now discuss the second isolation level. The second isolation level that I want to discuss what was read committed. Okay, where can this be used in reality? So everybody in the class, I am giving you this as a homework. Try to come up with some examples which you can actually, in which you can actually be using these kind of isolation levels. Does that make sense? Do you guys want to do that? Just think about all the possible things in the world and see कि किस system में I would be fine with coming up with a read uncommitted system. And trust me, there would not be many systems in which you can do that. In fact, at this point in time, right now, I cannot think of a real life system which would be actually using read uncommitted. Does that make sense? But do not take that statement as a statement which I'm saying it is not possible to build one. Yes, it is totally possible to build one, but totally depends on the kind of use case that you have. Do you guys appreciate it? Just take it as a homework. Think about it. In the next class, if you want, I would be more than happy to listen to what you guys think and more than happy to correct you if you are thinking in the right direction or not in the right direction. Does that make sense? Does it look like a good homework to do? Please do it. Okay. And actually, I've been giving you guys homeworks for the last class as well, but we never actually came back and discussed those. So let's not do it. You guys can actually remind me and we can have a discussion on this in the next class. Okay. Cool. So let's now come to the read committed isolation level. The read committed isolation level has two guarantees. The first guarantee it has is any data that you read will be committed. Does that make sense? So any data that you read will be committed. So the problem that we saw here, जो user to वो कट गया था, that won't happen. ठीक है? That won't happen here because you can only read a data once it's committed. Does that make sense to everybody? Make sense? There is another property here. The property here is that it will not overwrite uncommitted data. Or let's not call overwrite, the better word is override. It will not override any uncommitted data. So the uncommitted with a single T aayega. So they are not going to override any uncommitted data. What does it mean? It means that let's say there is some transaction which is going on, which is going to update some value. And let's say some other transaction comes and it also wants to update the same value. Does that make sense, folks? Same or similar elements in the similar rows, or let's say similar kind of data. You would not want to do that. So how will that happen? Let me just actually tell to you exactly how does that happen. Okay. So that happens because the transaction is going to have a read or a write lock on the current row. And this prevents actually, so it will not allow any other transaction to overwrite an uncommitted data. For this, do you understand that having a write lock on this data will help? Write lock on that entire data will help. And it will not allow you to read before it's committed. Do you agree that this will essentially mean that you have a read lock till it's committed? So I just told you how this is performed internally, but these are the guarantees that you see. Any doubt till this point in time, folks? Any doubt till this point in time? No, right? Cool. So read committed will say, can you explain the write lock? Okay, Parul. So Parul, write lock basically means that you are having a lock on some kind of a data and preventing anybody from writing on it. Have you read locks in OS, Parul? So locks basically means that you are actually limiting the number of people or limiting the access of a particular data to some folks, to some threads. Okay. Now the point is read lock basically means that you are preventing anybody else to read from it. Write lock basically means that you are preventing anybody else to write on it. Now Parul and everybody else in the class, can you guys tell me which right is going to be more right also prevents reads. Okay, so Manish, that is a that is a question that you are saying, which is a which is a question which depends a lot on definitions. So in my definitions that I am going to use, when I say read lock, it only prevents reads. When I say write lock, it only prevents write. Does that make sense? And in general, you will see a lot of cases where you can allow folks to read but not allow them to write. Does that make sense? Does that make sense? There will be a lot of cases in which you can say कि भाई write मत करना, पढ़ना है तो पढ़ लो, कोई दिक्कत नहीं है मेरे को, पर write करोगे तो मेरे को दिक्कत होगी, right? So there are a lot of real life cases where you can actually see that. In my definition, whenever I see a write log, it only means write. Whenever I see a read log, it only means read. Cool. Okay, so we discussed read committed में क्या guarantees मिलती है, but there is a problem here as well. Let's try to look at that problem. Okay, so let's assume there are two pieces of data. Okay, Vaishali says book my show seat booking is an example of a write lock. You tell me, Vaishali, if you're actually saying that I would want to write, I would not want anybody else to allow कि यार write मत करना इस पे, and I would want you to read on it. Do you think there is a problem? There is a problem. The problem is कि let's say you are trying to book your ticket, somebody else wants to book it, तुम उनको कह रहे हो भाई देख लो यार सीट तो अवेलेबल है, वो बेचारा अपनी गर्लफ्रेंड से बात कर रहा है कि hey man this seat is available, should I book it? And when he actually goes to book it, you tell him कि no I won't allow you to write on it because I only wanted you to read from it. That would be a very bad design, right? क्योंकि अब now if you want him to go back to his girlfriend and say कि नहीं I could not book it, there will be a lot of real life problems that book my show is now causing in that relationship. Does that make sense? So you would understand that and that actually happens at book my show, right? So you would see that whenever, let's say you logged in from one computer, from one account, you are looking at 4 seats and you did not go through the payment. Now you log in from your friend's computer, those 4 seats would not be there for you to book for some time. Does that make sense? Have you guys seen that? So you would actually have to wait for that timer to end so that then you can book those 4 seats from the different account. Okay. So you would also want to have some kind of a read lock as well when, okay. I hope it makes sense. Cool. Now let's come back to this. Let's look at the problems that you're going to see at read committed. So let's say there are 2 pieces of data. There is a piece of data account 1 and there is a piece of data which talks about the balance in account 2. All this sits in a DB. Okay. Now there is a user, a single user for now, let's say, and he is the man who has both these accounts with him. He has account 1 also with him. Account 2 also is his only. Account 1 had 500 rupees, or let's say he is very rich. Let's say that account has 500,000, which means 5 lakhs, and account 2 also has 500,000. Okay. So that guy does not want to transfer 100 rupees. He deals with lakhs. Okay. So he has 500,000 in one account, 500,000 to second account. Cool. Now he is feeling bored. He wants to transfer 100,000 from account 2 to account 1. Does that make sense? So he wants to transfer some amount of money from the account second that he has to the first account that he has. Okay. And now this is the time axis that you see, a time axis for this piece of data, a time axis for this piece of data. Does that make sense, folks? Now, let's say or let's say this was a joint account. Let's say this was a joint account. There was a couple who jointly held this account. Okay. Now let's say this is the husband, this is the wife. Wife was feeling bored and she wanted to transfer some money from one account to another, and she performed a transaction to do that. Okay. She performed a transaction to do that. And let's assume her transaction began from this time interval and ended at this time interval. What was that transaction like? That transaction was I want to transfer 100,000 from account 2 to account 1. And what will that transaction look like? You guys would be very happy to appreciate that. First of all, the transaction would be some gets and some sets. But let's say I ignore the gets. I only talk about sets. Let's assume कि हाँ उसके पास पैसे थे, because otherwise it will be a very big timeline to draw. Let's assume first of all it will be a set X, set account 2 to 400,000. Does that make sense, folks? The second statement in this transaction would be that set account 1 to 600,000. Does that make sense, folks? Does that make sense? So you have two operations here. Set account first to 400,000, set account second to 600,000. The transaction starts here, ends here. Now the husband is sitting at home. He is also feeling bored, but he cannot transfer the money without asking his wife. So he is just feeling bored and he just wants to access the amount in the account. Okay, that's all that he can do. Let's assume. So what will he do? He also runs a transaction, and his transaction is basically get the value of the money that is there in the accounts. Okay, so he runs a get value in both the accounts, and internally his bank will run a transaction, and that transaction will comprise of two get statements. Get X. So let's say get X from this account will tell him how much money. Folks, how much money will he see here? 500,000, right? Because the thing says that it will only allow you to read committed data. Does that make sense? The last committed data till this point in time was 500,000. So he will get back 500,000. Now let's say husband's luck is not good and something bad happened at the bank's end and this transaction got delayed. Okay. Somehow something bad happened and the second part of the transaction happened after this time. Does it make sense, folks? So he does a get here, and the money that he will see will be, how much will that money be, folks? 400,000, because a transaction has ended and he will see the committed data, and the committed data was 400,000. Now and look at the transaction of the first guy. The transaction of the husband spanned from here to here. Does that make sense to everybody? These are the two transactions. Did I do anything wrong here? Is this totally possible? This is totally possible, right? This is totally possible. Now the problem is that husband will see, oh man, what happened? He will just feel that he just lost 100,000. Does that make sense? Because the two accounts sum up to 900,000 there, but they actually had 100,000 more there. Does that make sense to everybody? Does that make sense to everybody? Now he actually refreshes. If he refreshes his page and the bank actually does another transaction, then he will get the correct value. But for this point in time, he got a bad value. Does that make sense? And this is again totally not acceptable for a financial institution. Folks, does it make sense or does it not? Let me tell you why this is not at all possible for a financial institution. Because this could have been swapped as well. You could have seen 500,000 plus 600,000, which would have made the husband feel that he has 1100,000 in his in their collective bank accounts, and he could have made a purchase at that very instant, which could have actually utilized that 1100,000 with only having 1,000 in a bank account. Does that make sense to everybody? Does that make sense to everybody? So in a banking transaction wali thing, this read committed will also not be sufficient. How many of you appreciate that? I'm pretty sure that there will be some of you who are feeling confused. Is there anybody who is feeling confused here? Do you appreciate that read committed is more guaranteed than read uncommitted, but still it's not enough? Does everybody appreciate that? Cool. The problem here is, let me write the problem also. The problem here is that you will possibly see inconsistent states, which can again make you unhappy. Cool. Let's now move to the third isolation level that we wanted to discuss, and that is snapshot. People, are you okay? Bishali, I will repeat that. Before that, folks, are you fine with me stretching this class till 12? I would want to complete this completely today. Is that fine? Okay. Anybody who is not fine with that, please feel free to let me know. If you're not fine, I will try to end it by 11:30. If everybody is fine, I can stretch it till 12. Okay, Moise has a problem. Okay, Moise. So do you have a okay? So do you want me to end it at 11:30? Uh, let me have a quick poll here. Let me have a quick poll here because I would not want to take a decision which uh, many of you are not happy with. So let me just have a quick poll here. Uh, Guys, can you see it? Uh, 9 people are still remaining to vote, and you guys, it's your vote which is going to make the difference. I see a good battle going on here. So please take a decision. Okay, we'll just wait for 10 more seconds. अरे भाई एक yes no click कर दो यार. चलो काफी. Cool. So 18 of you say that yes, you are fine with continuing with the class. 6 of you say that no, we are not fine. We have to leave early. Okay, so okay, is 22% good enough a number for me to not? Okay, so I will try to end it by 11:45. Okay. Cool. So I will just try to end it by 11:45. Guys, these are the results that you have selected. So I will try to end by 11:45. Okay. Cool. And then you can actually, we would just take 10-20 minutes in the next class and then move to the next topic. Cool. Yep. So the third point was that we actually want to discuss the snapshot. Snapshot basically has all the guarantees till the second last, till the read committed. With that, you give another guarantee that any transaction is going to see the data which was at the beginning time of the transaction. Okay, so what does that mean? It means that you are starting a transaction. Every transaction will have a starting time. Does it make sense? Every transaction will have a starting time. And the read committed gave us the guarantee that whenever you are reading, you will only read a committed state. Does that make sense? So read committed gave you a guarantee that you are never going to read an uncommitted state. But the problem was that you may be reading at different points in time in a transaction, and the committed state will be different at different points in time. Does that make sense? The problem with the second approach can essentially be boiled down to saying that even if you are giving a guarantee that you are reading a committed data only, the problem can be that the committed data can be different at different points in time, and the transaction can span a non-zero time. Does that make sense to everybody? This is how you can mathematically put it, right? To resolve that issue, you just say that I am going to give you another guarantee that no matter how big your transaction may span, you are always going to read the data which was there at the beginning of the transaction. Does that make sense to everybody? And the beginning of the transaction will be a single unit of time, and at any given point in time there cannot be more than one committed states. Does that make sense? Now Nikhil says of which transaction? So Nikhil, the transaction which is trying to fetch data, you will give the data at the beginning, which was there at the beginning of that transaction's time. Does that make sense to everybody? Let me just try to explain it to you in this example. Okay, should I try to explain it to you in this example, folks? Okay, so let's look at this example here. Let me use a different current color pen now. Let me maybe use a green pen. Okay, cool. So the problem here would be that this transaction is only updating some data. Does it make sense? So ये तो read कर ही नहीं रहा, so nothing changes for this. Folks, does it make sense? I am trying to give you the difference between read committed and snapshot. Nothing changes for this transaction, but for this transaction, I am doing two reads. The guarantee that I'm giving you now is that whatever you read will be read based on the time that you saw at the beginning of the transaction. So this transaction was beginning at this time interval. This get will also give you the data which was present at this time interval. So at this time interval, the X account 1 key value was 500K. And even when this get was happening at this time, but this get will also return you the data which was present at this time, which was again 500K. So even when in the beginning, in between, you had your wife, which actually transferred some data, but at least the husband will not die of a heart attack because he will still see the consistent state of being 500,000 plus 500,000. Does it make sense? Exactly, Deepika. That's a very, very good question to ask. That's a wonderful question to ask. Let me try to answer that for you. Everybody else, did you get what I just said? Did you guys get what I just said? Okay, just give me a time. Just give me a moment. I have received some message. I need to reply to it. Just give me 1 minute. Cool. So now, a very, very good question that Deepika is asking. Deepika is saying that how will the snapshot actually work internally? How frequently will the system be taking snapshots? How many of you feel that that's how many of you have any question answer to that solution and that question? First of all, let me ask you, is it possible that the system will keep on taking snapshots Hamisha of the entire database? Every second or every few seconds, is it possible? It's not possible. Did we discuss that already in the previous class? Did we discuss that already in the previous class that snapshots are very, very heavy and you cannot just keep on taking snapshots? We discussed that, right? So snapshot here does not mean that you are actually taking a snapshot of the entire DB at every given point in time. Okay. So before that, let me just tell you what guarantee this gives you entirely. Just one added guarantee that it gives you before the previous wala isolation level is that it will tell you that whatever you read is always going to be consistent. So यहाँ पर हमने पढ़ा था possibly you can see inconsistent states together. Here you will see whatever you see is going to be consistent state only. It may not be the latest state, but it will definitely be the consistent state. Cool. Now, how is snapshots implemented internally? For that, I will give you this term. Have you guys heard about this MVCC? Have you guys heard about this? Okay. Yes. No. 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 Okay. So this the full form is multi version concurrency control. Okay, so multi-version concurrency control. What does it mean? It simply means that you are going to maintain multiple versions for every, you are going to maintain multiple versions for every data point so that the snapshot can work. Okay, so what would it happen? For every object, you do not store only one value, you store a group of values. You store a group of values. How do we store a group of values? So, Deepika, whenever a transaction begins or whenever a transaction ends, do you agree that the values will only change, a consistent value will only change, a committed value will only change when a transaction ends? Does that make sense to you, Deepika? Okay. So what you need to do is to have some sort of a map in which you have a key value pair. The key is the timestamp and the value is that value. So I will tell you how it happens. So let's actually try to look at in this example only. Okay. So there are, how many data points are there, Deepika, which are getting changed? How many data points are there, Deepika? There are 2 data points, right? So there are 2 data points. There is a data point account 1. There is a data point account 2. Let's now first of all build the data for account 1. Account 1, and let's say the very first entry in every data point would be the value of it in time 0. Does it make sense? So at t is equal to 0, can you tell me the value of account 1? It's 500,000. Does that make sense? Now let me call this time as, let me call this T1, T2, T3, T4. So I've given a timestamp to every starting and every ending point of every transaction. Do you guys see that? I have given 4 timestamps here, T1, T2, T3, T4, which are the starting and ending points of these transactions. Now, you guys tell me, when this transaction is starting, do I need to have another entry for account 1? When any transaction is starting, do I need to have any more entry of that account 1? I need not. But when that transaction is ending, do I need to have another entry of that endpoint? Yes, I need to have, if that transaction was updating that value. Does it make sense, folks? So first of all, T1 की वजह से no entry, T2 की वजह से no entry because it's a starting point. Then you will see T3. Do you want an entry for account 1 in T3? Do you want an entry for account 1 in T3? Yes, you want. Why? Because that transaction did make a change to account 1, and now you would want to have an entry for this object at t is equal to 3. And the value would be, the value, folks, would be 600,000. Does it make sense? Now let's actually build the same thing for account 2 as well. T0 pe, let's assume the value is 500,000. Now T1 pe nothing changes because it's a transaction beginning. T2 pe nothing changes because it's a transaction beginning. T3 pe changes because it's a transaction end, and that transaction modifies the value. So you will say T3 is equal to 400,000. T4, it's the end of the transaction, but still nothing changes because you are not modifying anything in that transaction for that data point. Now, let's say when you are actually doing this get, account 2 is T2. Do you have any doubt, Suhail? Do you still feel account 2 के अंदर the entry should be T2? It's not the case, Suhail. Do you want me to unmute you? How many of you feel in the class feel that it should be T2 for account 2? Let me unmute Suhail in the meanwhile. Hey, Suhail.
Yeah, hi.
Yeah. Why do you say that it should be T equal to 2 for account?
Because the value of account 2 is changing at time equal to 2. We update set account 2 equal to 400k.
Uh-huh.
At T2 we are changing the values in account 2.
No, we are not changing the value of account 2 in T2. We actually change the value of account 2 at this time, which is something which is greater than T2. But
Okay,
this
okay.
was a partially committed state. Do you understand?
Yeah, yeah, I can
I
understand.
told you that in read committed, you are only going to read committed states. So at this time, let's call it T dash, which is greater than T2, nothing really changes because nothing is getting committed completely. Okay.
Okay,
And
okay.
these kind of entries that I'm maintaining, this is called MVCC, multi-value, multi-version concurrency control, which just maintains multiple values for every data point so that you can enable you, so that to enable you to have actually have snapshots. Okay.
Okay, I can understand.
Okay. Thank you. Can you use a different color for partially committed transactions? Okay. अब ठीक है यार मैं चेंज नहीं कर सकता विशाली पहले बताना था यार ठीक है cool so let's do it now okay so Sangal says but MVCC is not for all DBs it's for Postgres not on SQL okay. So, Sankar, that brings me to one point that I wanted to say at the end of the lecture, which I will just say right now. The point is that we are discussing concepts. Okay, we are not discussing definitions as such. I am telling you concepts. You can see a different kind of a name in a different DB, in a different SQL server. It may not be called MVCC, it may be called something else. Okay. And in fact, let me tell you, even across different DBs, you would say some kind of different guarantees for the definitions that we are discussing. So I'm going to discuss serializability as the last thing that we discussed today. But let me tell you right away that the definition that we are going to discuss is going to be a theoretical definition for different implementations of RDBMSs. That exact definition is going to be different. Does that make sense? So every RDBMS will come up and tell you that, hey man, please buy my RDBMS because my RDBMS gives you the possibility of doing a serializable, running in serializability. Okay. Now you just cannot say कि अच्छा क्लास में पढ़ाया था कि यार serializable का मतलब ये होता है ये मेरे को बोल रहा है कि ये मेरे को वादा कर रहा है let me buy it. Right? The point is you actually will have to you will actually have to go through the in-depth definitions of that particular instance and see what exactly they mean by serializability. There would be a few changes and then you can make a choice. Does that make sense to everybody in the class? We are discussing theoretical concepts here for exact definitions of different instances. You are going to see slight different variations. That's it. These are in general definitions. Does that make sense to everybody? Sankalp, does it make sense? Cool. That's great. That's great. Cool. Let's move on. So now Deepika, as you asked, we now have different states for this data point, account one and account two. Now, when a GET request happens, we know that this is a transaction which started at T1. So I will be now doing a binary search for account one to find a value with the last value which is less than equal to the time that the transaction began at. Does that make sense? So these are sorted values. Does that make sense to everybody? The time intervals are sorted in these multi-valued wala data structure that we are having. Now, if I just do a binary search and figure out the last value, which was where time was just less than equal to the time that I'm talking about. So the time that I'm talking about is T1 because the transaction started T1. You would realize that last time would be T0. Does that make sense? And similarly here also the last time would be T0. And that's why you will get 500,000 here, 500,000 here. So it's not as if you are taking a snapshot every clock cycle. You are taking a snapshot for a data specific snapshot after every transaction ends. And you are taking the snapshots of the data points which that transaction changed. Does that make sense to everybody? And now you will realize that as time goes on, the transactions will keep on getting ending. And now you can also delete some entries from this data structure because at a given point in time, there will be a time where T0 does not make any sense for anybody because यार 10 साल हो गए बाल सफेद हो गए अब मैं T0 सेव करके क्यों रखूंगा क्या फायदा कोई ट्रांजैक्शन नहीं चल रही है उस काम के लिए so you can just have a cron which will keep on removing that data points from the data structure. Does that make sense to everybody? How this thing gets implemented, how snapshots get implemented. Cool. I hope it makes sense. Now let's actually go ahead. Uh, Now let's actually see a problem with snapshots, and then we can move to one more level of serializability, isolation, and then we can discuss dirty reads, phantom reads, and so on and so forth. Cool. Huh. So let's take an example for an issue with snapshots. Let's say this is a very, very famous example. Let's say there are two doctors, or let's say there are so many doctors. Two of them happen to be Alice and Bob. I just write Bob's. Bob's is not the name of the doctor. The name of the doctor is Bob. So there is a Dr. Alice. There is a Dr. Bob. They are performing some duty at a hospital, and the hospital has a rule that for every particular shift, there must be one doctor which is on call. Does that make sense? The hospital has a rule that for any particular shift, there should be at least one doctor which should be on call. Folks, are you with me? Are you with me? It's 11:24. We still have 20 minutes. Cool. So the rule of the hospital is that for any given shift, so let's say there are 30 minutes or let's say 3 hour shifts. So every shift is 3 hour long, and there should be at least one doctor on call for every shift. Now, doctors are humans. They also want to take leaves. They also want to say that, hey man, I'm not available. I'm busy with something else. I'm going and watching a movie that I book my show, and now I'm going to watch a movie. I cannot be available for this particular duration. So now the hospital has come up with a rule which says the moment you request and tell us that I will not be available at this particular timestamp or this particular shift, I will run my algorithm to figure out if there are more than equal to two people who are available at that point in time. If there are greater than equal to two people available at that time, you can very well take a leave for that shift. Does that make sense, everybody? By default, everybody is marked present for every shift. Whenever you request for a leave for a particular shift, the hospital's algorithm will check whether there are at least greater than equal to two people at that shift. If there are, you can actually say that you will not be available and I can give you a leave for that shift. Does that make sense to everybody? Now, if we want to implement this, and you would be actually seeing these kind of problems in a real life interview. In real life interviews, you have machine coding rounds these days, right? You have code pair rounds these days. You have managerial discussion rounds, right? They will give you problems like these, exactly the problem that I gave you. And they will ask you to design it. You can either try to handle it at the application level. If you try to handle it at the app server level, the problem would be that if that app server now gets distributed across multiple servers, then you would be in a fix. Does that make sense, folks? You will actually have to come to this definition of DB. You will actually have to come to the isolation levels that we are talking about and explain to the interviewer that, hey man, I will go with this isolation level, which will allow me to solve this problem. And if you do it good, you are automatically selected for that round. I can assure you that if I see a candidate which can explain this to me very well, I would not be rejecting that candidate no matter what happens. Okay? Cool. Cool. So 3 hour shift, okay? And let's try to define it. So I would be, just because I want to handle it at the DP layer, I would be wanting to define transactions. Does that make sense? I would be willing to define transactions. Let me define one transaction. My transaction begin here. First of all, I would do one thing. I will say that I would want to get the number of people who are currently on call. Okay. Okay. So Kanya, we are going to discuss that in great detail when we actually go to the backend classes. You are going to define some of it in the app server code and some of it actually at the database. So the point is, you guys would agree with me that there are libraries for different languages for different databases. Have you guys seen that? Let's say you were using MongoDB in Python. There would be a library for MongoDB in Python, right? Let's say you are using PostgreSQL in Python. There would be a library in PostgreSQL, let's say So yeah, you guys would remember the name of the libraries. Yes, PSYCOPG2. This is a library for PostgreSQL in Python. Now, you can very well implement these things using your code, using a library, or you can very well actually log into the box and define some things there. Do you guys agree with that? So let's say you want to create a table. You can very well do it from your code in Python, or you can very well go to the box and create a table, right? So all these things, yeah, Sankalp, you're absolutely right. I do not want to discuss that because we have not discussed that formally in the classes yet. We are going to discuss that once we actually go to the backend classes. I hope it makes sense to you, Sankalp. But yes, that totally makes sense. So we are going, there are different ways of doing it. Nothing really changes conceptually. Cool. Let's move on. So you are going to figure out, write a query which will give you current on call. The query will be something like this. You are going to say select all from doctors where on call is equal to true and shift ID is equal to, let's say, 123. So let's say somebody is asking for a leave at shift ID 123. This is the first query that we are going to call. Figure out ki bhai kitne log hai. So let's not call select all. Let's call select count star. Does that make sense? So we'll want to figure out ki how many people are there which actually are on call at that point in time at this shift. Okay. Now you will check if on call count is greater than equal to 2. If that's the case, you will say, hey man, I would want to update the doctor's table. And I would want to set on call is equal to false. Hey man, this doctor is not available. Which doctor? Where doctor ID is equal to, let's say, 701 and shift ID is 123. Does that make sense to everybody in the class? Is this a valid SQL transaction to write, which can help us do this? Folks, are you with me? Are you with me? Okay. Now, I would ask this question to everybody in the class. If this is a transaction that I'm talking about, and I am using snapshot level isolation, will this solve my problem or will this not solve my problem? Think about it. Take a minute and tell me. And do not reply publicly. Reply privately. There are multiple doctors, Narayan. There is a Alice, there is a Bob, there is a Narayan, there is a Sanket, there is a Priyanka. There are 5 doctors and they want to do this. Okay. So think about it, folks. Will this work? So did you get the question? Did you get the question that I was asking? Will this work at a snapshot level isolation if I write this transaction and I want this to happen? How many of you get the code? How many of you did get it? What I'm just saying. You get it, right? You get the question. I've got 2 answers already. What about the others? Give me the answers, folks. Okay, Sanket. Okay, Sukanya. Okay, Nikhil. Okay, Vishali. What about others? Think about it. Sanket, do you want to change your answer? Okay, Vishali, Nikhil, do you want to change your answer? Narayan, do you want to change your answer? Okay, Narayan, makes sense. Sukanya, just hold on for a while before I tell you whether you are right or not. This is the best way to actually figure out how many of you are actually sure about your answer, right? The best way to check whether somebody is sure or not, and you can see that in the interview as well. The interviewer can just ask you whether you are sure about it. The folks who gave the correct answer and were just making a random guess would be the first one to say, nahi yaar, no, that's wrong. I just gave a wrong answer. I missed that. The answer was not that. The answer was that. And then the interviewer will say, yes, he will just say, I just played very well and figure out a person who was trying to give me a random answer. Right. Makes sense, Sanket? Lokesh, makes sense? Okay, cool. So the answer to this is that this will not work at the snapshot level isolation. Would anybody want to volunteer and explain to the class why this would not? Okay, let's just skip that. We don't have much time. Let me explain it to you right away. This will not work because the problem can very well be, let's say, okay, this will not work because let's say the first person who wanted to figure out whether he can take a leave at that particular shift or not, started his or her transaction at, let's say, this point in time. Okay, yeah, I will use a diagram. So let's say the transaction for the first person started here, ended here. Okay, let's say this transaction for the second person started here and ended here. Does that make sense, folks? Now, before the beginning of any transaction, let's say on call on that particular shift were equal to 2. There were 2 people who were on call at that particular shift. Now this guy started here, he figured out that there are 2 people, and just because there are 2 people, he would also run another query to update it and set ki bhai main available nahi hu. Does it make sense, folks? And once he is not available and everything gets committed, the number of people on call will be 1. Does that make sense? Makes sense. But this transaction got committed at this point in time. Now the second person read at here, and he also was doing some things here. But as I told you that whatever read you do in a snapshot, you will read the value that was there before the transaction started, at the time of the transaction started. So at the time of the transaction starting, there were 2 people on call, but before the transaction could end, there were only 1 people on call, and you would realize that both of them will get a leave, and that's a bad thing to do. Does that make sense to everybody? Does that make sense to everybody? That snapshot isolation level will not work for a problem like this. Archit wants me to repeat for sure. Archit, do you want me to unmute you? Let's have a discussion, man. Sure. Let me just unmute you very quickly. Hey, Archit.
Yeah, hi, hello.
Yeah. So the point here is that, first of all, do you understand what a snapshot thing does?
Yeah,
In
yeah.
snapshot, every guarantee that was there in a read committed is there. So what all guarantees were there in a read committed? We had these 2 guarantees that any data that you will read will be committed. You will not read any data which is uncommitted, and you will not override uncommitted data. Does that make sense? Are you there?
Yeah, yeah, hello. Yeah.
Okay, makes sense. So now the problem here is that if you are using a snapshot level isolation, the problem would be that maybe both of them started at some random times. And let's say when the first one is actually checking whether there are enough people out there, enough people on that call or not, he figured out that there were 2 people, because whatever read you do at snapshot, the read you do at snapshot is at the beginning of the transaction. Does that make sense?
Yeah.
When the first transaction was happening, beginning here, you would realize that at that point in time, there were 2 people on call,
2 people, yeah.
right? And once it ended, then there were only 1 people on
2
call.
people on call.
Okay. And now the second transaction that was starting, here I was reading, and I told you in snapshot, you read the thing which was at the beginning of time, at the beginning of your transaction. So at the beginning of transaction, there were 2 people on
2
call.
people on call, okay.
And then you found out that yes, that's great. And when you were executing it, at that point only 1 people were on call. But you always read at the beginning of the transaction, and you feel there were 2 people on call, and you also mark yourself ki bhai may be available nahi hu. After this, the people on call will be 0, which is not as per the definition of the hospital rules, and there will be an issue.
Makes sense, makes sense. Got it.
So thank you, Archit. Thank you. So Lokesh says patients will go on strike. So Lokesh, in no country you will ever see patients going on strike. भाई मैं सरकार से नाराज हूँ, सरकार बहुत बुरी है, मैं बीमार हूँ, but I am on strike. I will not go to work. Oh, but that's happening these days. Oh, that's actually happening these days, right? That's actually happening these days. People who are sick are not going to the hospitals because they feel that they should not. And I don't know why they feel they should not, but yeah, that's actually happening, right? You actually are a step ahead of me. That's great, Lokesh. Cool. Let's now move ahead. Okay. Now, let me actually give you the basic thing where this will not work, right? Where exactly, Vaishali, you're absolutely right. But in fact, I would say even more worse than that. Maybe there is no comparison. Both of them are equally worse. Makes sense. Cool. Now, let's discuss about where snapshots will not work. Okay. Snapshots will not work in competing cases. In any case where you see competition, where you see people or things competing for the same resource, snapshots will not help. Folks, are you with me? Whenever you see competition for the same resource, snapshot will not work. Let's take some more examples. Vishali, I will unmute you. Let me just give some examples. So let's say you are actually trying to book a railway ticket at IRCTC, right? Everybody is vouching for that same seat, okay, in a Tatkal booking environment. Would snapshot work? No, it will not work. ठीक है. Similarly, let's say everybody is trying to book a ticket on Book My Show. Will snapshot isolation level work? It won't work, right? Let's discuss about banking transactions. There is a resource which is money. There are multiple people, multiple things which are actually coming after that money, right? So snapshot will not work. ऐसा नहीं हो सकता कि बैंक कहे कि यार ठीक है भाई, जब तूने एटीएम कार्ड स्वाइप किया था तब तेरे अकाउंट में पैसे थे, बीच में से कोई ले गया पर कोई बात नहीं यार, चल तू भी क्या याद रखेगा, ले जा पैसे, ठीक है. That's not how things will work, right? So now let me unmute Vaishali and let me unmute. Okay, Vaishali says what happens if the transactions start at the same time. Okay, if the transactions start at the same time, so that would never happen. That would never happen. Transactions, or in fact anything. Let me just try to figure that out. Let me just try to wrap my head around it. It would never happen, Vaishali, but because the point is, it's always, so the epoch time would always be different. The epoch time would always be different. But let's just try to feel what happens if they happen at the same epoch time. So let me unmute you, Vaishali. You give me what exact case you want me to answer, and then we will try to formulate the answer for that. Okay. So let's just hold on for a minute. Oh shit, my system is out of application memory and I'm not able to unmute you. Just give me a minute, Vishali. Let me try to unmute you. No. Hello. Can you guys hear me? Cool. So let me actually tell you a real life thing that I just faced, which mimics. Okay, you can't see my screen for just a minute. So let me just tell you what was just happened. I will just take a minute and explain to you what just happened. So because my system was out of application memory, by mistake I switched off Zoom. I already had that in mind that I would not be doing that, but somehow I was trying to close Google Chrome, but the Zoom got closed. So okay, that's fine. Now when I was trying to rejoin, I rejoined, and then I was trying to unmute myself. Okay, I was trying to unmute myself, but I was not able to unmute myself. Why? Because Zoom was saying that I am not the host, and the host has muted everybody, and you cannot unmute yourself. Does that make sense? Right. So I was not able to unmute myself, and I waited for a while, and then I was able to unmute myself. Okay. So you guys think about it. what kind of a isolation level would they be using, and just try to utilize whatever we discussed today and appreciate that why that would have happened. That is very, very similar to what would have happened to in case when you are booking for book my show tickets, or let's say you are booking a flight ticket. Let's say you are in middle of that transaction, and before nobody else would be able to take that control of of that particular data point, because somebody else has a lock on it. Does that make sense to you guys? Does that make sense to you? So once that timed out happened and that transaction was forcefully shut down, that thing was forcefully shut down, then I was able to become a host and I was able to unmute myself. Does that make sense? Cool. So it's 11:43 already. We wanted to discuss a couple of more things. We'll be discussing that tomorrow. In the meanwhile, let me take Vishali's doubt and I can answer that. And then we can call it a day for tonight and discuss whatever is remaining in the next class. Is that fine with everybody? Is that fine with everybody? Cool. That's great. Yeah, Vishali, let me just unmute you and let's have a discussion and then we can end the class. Abbe yaar. एक second रुकना जरा. Cool. I will be able to unmute you now maybe. I have closed everything, but I'm still not able to. Yeah, I can. Yeah, hey Vishal.
Hi, Karun.
Yeah.
Can you just scroll up to that diagram you had made?
This one?
So my question is कि now T2 के बाद if I start at T3 midway, फिर वहाँ से T4, बीच से T3 का, then again at T5. When would I actually end up updating
Yeah, I
my
didn't.
snapshot
So
to the next value?
you're trying to say it like this, T3?
Yeah, like that.
And then you want to say something like T4?
Yes, if a situation like this arises, when would I ultimately update my snapshot ka value to a new snapshot?
Okay, that's great. Deepika, are you there in the class? And would you want to answer that? You were the one who asked me that question that time, and I hope that you would be able to answer it. Deepika, can you take up and answer that for your friend? Yes, you can. Cool. So Vishali, I would just maybe keep you unmuted only, but do not speak over Deepika. Let's just unmute her as well. Yeah. Hey, Deepika. Hello. Hello. Can anybody hear Deepika? No. I see there is some issue, Deepika. Okay, not an issue, Deepika. So I will explain it for you. Okay, I am assuming that you got it, but I will explain it for you. Okay, so I'm muting you back. Thank you. And okay, the point here is, Vishali, that look at the definition that I gave you. The transactions, the data point will be updated when a transaction ends and when that transaction was updating something for that data point. Okay, so here the data point is number of people on call. This transaction ends here, and this transaction was updating this. Does that make sense, Vishali?
Yes.
So if that makes sense, so first of all, there would be a T0, जिसमें I would have, let's say, X people who are on call. Let's say 40 people on call. One transaction once end here, let's call it T1. At T is equal to T1, you will update it and make it 39 because this is a transaction which is updating it and it's ending.
Correct.
Now when at T2 this ends, this is again updating it, and at T8 equal to T2, you will make it 38 and so on and so forth. So there is no issue in that, Vishali.
Right. I was thinking there might be some interleaving of sorts, but
there is none, right?
There is none, yeah.
Okay, thanks a lot, Vishali. And I think we can end the class here. Anybody has any other doubt? Can two transactions start at the same time? Okay, I will actually come back to you guys with that. My understanding is that no two transactions will be able to actually happen at the same epoch time. So do you guys know what is the epoch time? If not, just read about it. What is the epoch time? And you would understand that basically the time at which a clock, that basically is the time which tries to, well, there's a clock running inside your computer, which is actually incrementing that epoch time every instant. Okay. So the point is maybe no two transactions that start at the exactly same epoch time. Even if they do, Sohail, I would come back to you and tell you whether that's possible or not. But even if they do, I do not see anything that we talked about breaking. Nothing will break even if they happen. Okay. And Sohail, if you can come up with an example where it will break, I would be happy to discuss it even right now or maybe tomorrow as well. But just hold on to that thought that nothing will break even if two transactions start at the exactly same time. Sohail, does that make sense? Cool. Any other doubt, anybody? Okay, I hope not. Does Git command work on transactions? Okay. So Sukanya, okay. So that's in fact a very good question to discuss. We can actually, and I've seen that question being asked at different interviews as well. Not maybe in the high-level design interviews, no, it does not make sense. But we can actually discuss how to design a Git-like system. But yes, Git commands. You can also very well say that this would also be some sort of transactions going on, at least at a theoretical level. Does that make sense, Sukanya? You'd be able to see a lot of similarities, and at a theoretical level, you can say those are transactions. Cool. Okay. Yes, Narayan, you're absolutely right. That would be set for the entire. Okay. So okay. So transaction isolation levels are set for sessions. So let's say I can at the very same DB, I can log into my DB and say, "Yaar, abhi se I would want to run things at a snapshot isolation level." Okay. After two hours, I can log in and say, "Yaar, ab se mera man badal gaya hai. Ab se I will have to, I will want to run at a serializable isolation level." Does it make sense to everybody? This is a very, very good question to ask, Narayan. I'm glad that you asked it. People, does it make sense? At the very same DB. So basically, isolation level makes sense for transactions. Guys, are you with me? Nobody's replying. That's strange. So isolation levels are for transactions, and transactions move with time. Does that make sense? So you can log into your DB at any given point in time and say कि आज के बाद से दुग्गल साहब डॉक्टर बनेंगे. So have you guys seen that meme? I do not know the movie, which movie that is a part of, but there is some character Duggal Saab which actually which actually who actually takes up different roles at different points in time. So you can actually say कि अब से मेरे transaction का isolation level ये होगा. Okay, cool. This is how IRCTC handles Tatkal. In what manner, Shubham? Yes, so maybe, you tell me, Shubham, would snapshot be a good isolation level for IRCTC, Tatkal booking? Everybody in the class answer that for me. That would not be the case, right? Because I just told you that whenever you have competition going on for a resource, we gave several examples. None of the levels that we discussed till now would be sufficient. And that would take us to a couple of more levels that we are going to discuss very, very quickly in the next class and discuss dirty reads, phantom reads, and so on and so forth. Okay. That's a good point to ask, Shubham. I don't know exactly how IRCTC would be handling that, but that can very well happen. You can change the isolation levels once that particular time frame is over, and then you can say some other isolation level is going to be fine with you. Does that make sense, Shubham? But the point is, even if you're not doing Tatkal bookings, even then you are actually running after the same set of resources. And okay, the question is that would IRCTC be handling the change from a Tatkal booking to a normal booking by changing the isolation levels? The very good answer to that would be no, because even for a non-Tatkal booking, you would see that people are actually fighting for the same set of resources. Does that make sense, Shubham? It would not be the case that there are 80 seats for a coach to be filled and you booked 102 tickets. It would not be the case, right? You may book 102 tickets, but for the remaining 22 people, you would have to give them waitlist 1 to waitlist 22, right? So maybe there are not enough read locks. So try to appreciate. Maybe there are not. Okay, so have you guys tried booking from IRCTC? Have you guys tried booking from IRCTC? There is an option, if you have read it, there is an option which says book only if confirmed tickets are allocated. Have you guys seen that? Book only if confirmed tickets are allocated. Why do you see that option there? One, because it makes sense from a user perspective. कि भाई कोई भी यूजर होगा, हो सकता है यार मेरे को कोई फर्क नहीं पड़ता, तत्काल नहीं, मैं नॉर्मल बुकिंग करा रहा हूँ, मेरे को वेट लिस्ट भी दे दोगे, आई एम फाइन विद दैट, जस्ट बुक द टिकट फॉर मी. But appreciate from a system development point of view, if you want to make sure that you are only booking when it's a confirmed ticket available, you would agree with me that you are essentially saying that you want read lock as well. Does that make sense? On the other hand, if you want to say कि ठीक है मैं write करते वक्त check करूंगा कि इस बंदे को कौन सी टिकट देनी है कि नहीं देनी, book तो कर दूंगा, you essentially are saying कि read log ना भी हो, write log होगा, चलेगा काम. Does that make some sense to you guys? So essentially, if you have a system where it's totally fine with overbooking, right, and you can actually have a later, you can have a disjoint service which is actually giving you the seat number, it's totally fine to only have write logs and not read logs. Does that make sense to everybody in the class? I hope it does. Cool. So thanks a lot, everybody. I hope you guys enjoyed it. There is one request from my side. Even if you did not enjoy it, please fill the feedback, because I would be happy to know that which particular person is not able to understand what things, and I would be happy to correct it for you guys. Okay, so do fill the feedback. I am seeing very less feedback these days, even after I am spending. So trust me, I do क्या बोलते हैं, take these classes with a lot of heart, and please do fill the feedback at least. No matter whether it's positive or negative, do fill the feedback. Okay. Okay. Thanks a lot. Beshali, I would not want to do that, because the point is ki, there are different use cases, right? So I would not want the students to feel frustrated ki it's a blocking thing that you would have to proceed only when you can fill the feedback, right? That should not be the case, right? But it's just my request to you guys. So how do I get back? There is no option to get back, right? That's right, Beshali. So I would look into it and maybe ask somebody to implement it, so that at least you can actually go back to it and fill the feedback form later. That's a good point to be raised. But in the meanwhile, I would just advise that you do fill the feedback. It just helps me to understand how many of you are getting things, how many of you are not getting things. If there is a specific thing that I can do for some of you specifically, I would be more than happy to do it. Thanks a lot, Nikhil. I am really happy that you enjoyed the class. And everybody, thanks a lot for attending. Hope to see you again tomorrow. Goodbye. Good night. And one more thing, just one more small thing. So the point is that you guys would be seeing that we already have this. This was our 7th class, if I'm not wrong. 7th or 8th class already, right? And 8th class, right? And if I keep on going, I can potentially take 20 classes of high level design, right? But that would not make a lot of sense. So what I was thinking about is that I will take another 4 or 5 classes this week, or maybe till early next week. Then maybe we can ask you guys to go on and study advanced DS algos. Okay, I would just want you guys to tell me whether that's fine or not. Then for a week or 2, you can study advanced DS algos, and then I will again take maybe 4 or 5 classes. But that time I will not be taking that class only for your batch, but I will combine some other batch with you guys as well, and maybe take for a bigger class those remaining 4 or 5 classes. Is that fine with you guys? Is that fine with you guys? So maybe having to take another 3 or 4 classes abhi, and then moving to advanced DS algos, studying advanced DS algo for a week or 2. In advanced DS algo, we are going to study things like, let's say, lazy propagation of segment trees. There is one topic that I love to teach, and I'm pretty sure that you guys would also love to understand, that is network flows. So we teach network flows also in advanced DS algo. We would want to teach some advanced probability in advanced DS algo classes, and so on and so forth. So those classes are going to be very, very interesting. Bitmask DP as well, for sure. KMP, MST. Did we not cover MST? Did we not discuss MST till now? That's strange. Okay, so we did. Sankalp says we did. Okay, so yeah, you guys can just okay. So you guys can just maybe I can circulate a type form in which you guys can mark what all things you would want to be discussed in the advanced DS algo classes, and I would be happy to discuss those things. So once those advanced DS classes are over, then we'll come back to system design and discuss 4 or 5 more systems. I hope it makes sense to everybody. This seems to be a good strategy. Yes, cool. Now somebody asked, what all systems do we want to design? So maybe I would want to design something like a Uber. I would want to design something like a Hotstar, or what else? Definitely a Facebook Messenger. GitHub, maybe not. Dropbox, yes, we would want to design Dropbox, and maybe a couple of more systems. Okay, yeah, Uber I said so well. So yeah, Twitter we can design Twitter. We can design an e-commerce website. Yeah, so there are too many things to design, but the problem is we cannot have too many classes. The point is key, even when you see a couple of systems and you understand whatever we discussed in class, any other system, I am damn sure you will be able to discuss in the interview itna acha ki the interviewer will not reject you because of the high level design round. I am pretty sure if you take these classes nicely, you would only get brownie points out of any high level design interview, and you will only force the interviewer to accept you throughout. Okay? So just have trust on the process, go through the classes again and again, understand each and everything that we are discussing. Even if we end up discussing a couple of less things because there are not enough classes to take, that should not be an issue. Okay? And I'm always there with you guys, right? So even if, let's say, you are giving an interview somewhere down the line and you feel that something bad happened because of HLD, you can always come back to me and tell me ki yaar ye kya ho gaya, and we will figure out a way out. Okay? Cool. I was once asked, forgot password design visa. I wasn't sure. Okay, Suganya. So yeah, we'll see what all things we can discuss. Okay. Thanks a lot for being there till 12. Good night, everybody. I hope you guys enjoyed it. See you again most likely tomorrow. Okay. Bye, everybody. Bye. Good night. Stay safe, and let's hope our country gets out of this mess as soon as possible. Right? Okay. Bye.